Hello, I'm Garman. This is going to be on my lesson 1 of matter. And over here I have all 3 of my students. And we are going to get started. It's all around us. It comes in different states. What is it? With this unit, solids, liquids, and gas matter. Today we are going to talk about matter. Has anyone heard of the word before? Matter? What is it? Take a few moments and brainstorm your ideas with your desk buddies. I've heard a lot of great ideas floating around. Does anyone want to share what they came up with? How about you, Mr. Stuffed Animal? That's an awesome idea. It's everything. Great. Anyone else? All right, what about you, Mr. Dog? Great idea. Let's write it down. You can sometimes hold it. Great. All right. Can we get a few more ideas? Yeah. What's your idea? All right. It can be a solid. Oh, yep. And it could also be a liquid. Awesome. Let's write that down. Okay, how about we get 2 more ideas over here? Yep, what's your idea? All right, you can't always see it. Oh, that's a great one to put down here. Can't always see it. And how about one more? Yep, go right ahead. Good, it can be a gas. Great. All right, so by the end of the lesson today, you will all be able to tell me what matter is and what the states of matter are. To help us jump into the subject of matter, we're going to watch a video on study jams, and while you're watching the video, you are going to fill out this matter worksheet. You can fill this out throughout the lesson, and if you get any clues, go ahead, write down the answer, but make sure you write it in pencil just in case we have to share some or change some answers later, all right? So let me hand out all of our papers, and let's get to our study jams video. All right.
It's freezing out here, RJ. I can see my breath.
It has been pretty cold. Look, even the puddles are freezing over.
Yeah, gotta love those states of matter.
The where?
The states of matter. Solids, liquids, and gases. When things melt, when things freeze, like the puddle.
That's pretty cool.
What would you say if I could tell you exactly how cool that puddle needs to be to turn from liquid to solid ice?
I'd say game on, Zoe.
Okay, so matter is anything that takes up space as a solid, liquid, or gas. The state of that matter, solid, liquid, or gas, depends on how fast the molecules move. Just think of them as tiny players on a team. Our team is water today.
Now you're speaking my language.
All right, let's get rocking. We'll start with gas.
Okay. Gas.
Gas is the state of matter when the molecules move the fastest, like super crazy all over the place fast.
What makes them move so fast?
Heat. The hotter molecules get, the faster and more wild, crazy, and spread out their movements are. When they move like this, we see the water as a gas. Gas moves anywhere and everywhere it can.
Got it, Coach.
If you cool those molecules down, they'll move a bit slower. Take enough heat away, and those molecules will move close enough together to become a liquid, the second state of matter.
Exactly how close do they have to get to turn into a liquid?
Well, they've still got some room to move. That's why a liquid can change its shape.
So when the molecules get cold enough and close enough together, they turn from a gas to a liquid?
Yep, And when gas turns to liquid, it's called condensation.
Gas to liquid, condensation, gotcha.
Now, let's drop the temp even more. When the temperature hits 32 degrees Fahrenheit, that means freeze. This is called the freezing point.
Not much room to move when you're frozen together.
Right. When water freezes, it becomes a solid, the third state of matter. Solids are hard and don't change shape because their molecules have stopped moving around.
Sounds sort of uncomfortable.
Well, just add some heat and it's easy to change a solid back to a liquid.
Then let's get this solid fired up.
When the temperature rises above 32 degrees Fahrenheit,
the ice melts into a liquid again.
Right. This is called the melting point. If we crank the heat up even more, we'll reach boiling point and send those molecules into a frenzy.
And from a liquid to gas.
Yeah, and that's called evaporation.
Liquid to gas, evaporation. There they go, moving as far as they can. All right, let me run through this for you. Tell me if I got it right. There are 3 states of matter: solid, liquid, and gas. Adding heat or taking it away can change matter from one state to another. When matter changes its state, it's really the movement of the molecules speeding up or slowing down. That I do.
RJ, I'm impressed.
I think you just gave me an idea for a play to use in tomorrow's game. I'll have my players run in all sorts of crazy directions as far as they can, totally confusing the other team.
Oh yeah? You got a name for that play?
Don't you know? The Evaporizer.
All right, so now that we've looked at that video, let's get our vocabulary notebooks out and a pencil to write down some new vocabulary terms. And during this, you can also go through your fill in the blank page. And if you see any answers, go ahead and write that in. So I'm gonna pull up our PowerPoint for new vocabulary now. So you can go ahead and label at the top of your paper, Matter, New Vocabulary, Lesson 1. So as a new definition is brought up, go ahead and take some notes. And to start, let's look at our first word. Our first word is matter. Matter is everything around you. Atoms and molecules are made up of very small parts of matter. Those atoms go on to build things you see and touch every day. Matter is defined as anything that takes up space and has mass. Matter has volume. So make sure, I see that you got a little distracted there. Make sure you're paying attention and you are going ahead and writing down our definitions. So those atoms go on, and matter can be anything in this world, like we said before when we were writing down our ideas. So the next word that we have here is mass. So like I said, matter is defined as anything that takes up space and has mass. So mass is the amount of matter or substance in an object, and mass is measured with a balance. A balance is an instrument that's used to measure mass. And one common way of measuring mass is to go ahead and zero your balance and measure the mass directly. For example, this is how people measure their weight. Can anyone think of another way that we would use balance or a scale? Awesome job, you're right. When we go to the grocery store, we weigh out how much our fruit weighs, and then when we use the balance, it gives us how much the fruit will cost due to its weight. Great responses. Our next vocabulary term is going to be volume. So volume is the amount of space that something occupies. Words such as big, little, long, or short are used to describe volumes. Different states of matter will fill different volumes in different ways. An example of this, as you can see in the picture, so for this, there's 2 cups, and this shows how the water can be filled, can fill the cups in different ways due to the volume of the cup. So the smaller cup has less volume, which means there can be the same amount of water used, but in a bigger cup, there's more volume that can be filled up. So the same amount of water isn't going to fill the same cup the same way. If you have any questions, now would be a good time to ask. No questions? All right, let's start going on to our next definition. Kinetic energy. So kinetic energy is something that we need to understand for what makes a different state of matter. So kinetic energy is an energy an object has due to its motion. So as long as an object is moving at the same velocity, it will maintain the same kinetic energy. So like we saw in the video, each kinetic energy, so a gas moves fast. A liquid, they move, but they don't have too much room to move. And a solid, they stay connected and together. So there's much little movement in there. So, like we've been talking about, there are 3 forms of matter called solids, liquids, and gases. Let's start with a solid. A solid, the particles fit very close together, as you can see in this picture here. Solids keep their own shape and the atoms stay where they are. There are very small gaps in between the atoms, which makes it keep their shape. So let's look at our next definition, which will be liquid. So for the liquid, the particles are still close together, but they're further apart in comparison to the solids, as you can see here. There's the particles can move around and mix with other particles. Therefore, the liquids can change the shape due to its container or whatever it's put in. There is still very little space between the particles. As you can see, there's not as many white spots on, or white spaces in between the blue, which are representing the particles or atoms. Let's move on to our next definition, which is going to be gas. So with gas, the particles are further apart, as you can see here, in comparison to both the solids and liquids. There's a lot of space between the particles, which means they keep moving around. The particles collide, as you can see here. It's showing the movement between the particles, and they hit the walls of the container that they're in. And because the particles can move so easily, a gas will fill a container that it's put into. There's plenty of space in between the gas particles, like I've said. So here we're going to look at examples of matter in the real world. Does someone want to raise their hand and go ahead and read off one of the solids for me? Mr. Dog, go ahead. You're right. A clock is a solid. A clock stays its shape. The particles are very close together. Awesome. So now looking at the liquid section, can someone tell me why soup might be a liquid? Go ahead and look back at our notes for a liquid. Does anyone want to share? Mr. Dog, I see that you're getting a little distracted. How about we turn to this page over here? Yep, go ahead and look at our liquids. What can you use from the definition to tell us why soup would be a liquid? Go ahead and think about it in your head. Awesome. All right, does anyone want to share what they found and why they think a soup would be defined as a liquid? That's an awesome idea. Soup would be classified as a liquid because it can change shape according to the container it's put in, which means that the particle or the atoms are closer together but not so spread out. Awesome. Great. All right, looking over here, so we just had soup, but what about steam from a soup? Steam from a soup would be classified as what? Yep, go ahead. You're right, it would be classified as a gas. Great job. All right, so what I want us to do next, we are gonna, as a group together, we are going to look at these pictures here, And we're going to try to sort them as a class together as a solid, liquid, or gas. So if you need to turn back and look at your notes, go ahead and do so. So I'm going to call you up one at a time. Oop, let's go back up. There we go. I'm going to call you up one at a time, and you're going to come over here and use my mouse to click and drag one of the pictures you want to choose into a solid, liquids, or gas. And I'm going to give you a hint. There are 3 pictures for each category. All right? All right. So, when I call your name, come on up and drag a picture into the correct spot. Mr. Broccoli, would you come up and go ahead and find a gas and put it in the correct space? All right, Mr. Broccoli. So you are looking for a gas. Great job. The steam from tea is, in fact, a gas. All right, Mr. Sloth, would you like to come on up and go ahead and find a solid? Great job. A bike is a great example of a solid. What about you, Mr. Dog? Would you come up and find us a liquid out of the remaining pictures? Great. A glass filled with the water inside. The water would be a liquid. Good job. All right, so at this moment, I would finish this activity and go through all of the pictures and have each student, if I was in an actual class, I would have a different student come up for each picture here and fill out the examples list. All right, and let's get back into it. All right, so now that we've looked at some examples of the states of matter, with your desk buddy, I want you to use a dry erase board to think of 3 examples of states of matter. And I'm going to set a timer for 5 minutes. And then when we come back as a whole group, we'll go through different examples and we'll make one big chart as our class example list. So I'm going to set our timer for 5 minutes. So here I would hand out dry erase boards, which I do not have here at my home. I would hand out a marker to each group as well, and I would go ahead, play this timer, and give them 5 minutes to create different lists of examples. And then when we're done, I would get a big piece of paper, construction paper, and go ahead and write out each group's one example from each group. And then I would hang that up so the whole class can see that and have that as a source for them if they need to think of examples. Okay, thank you, class, for sharing this. I would love to hang this up right here at the front of our class. So if you ever need to think of examples, you will have that there. Okay, so next for independent practice, I'm going to be giving you each a handout here. And I'm also going to give you each a handful of Cheerios. Now, these Cheerios are not here to eat, and they're not here to play around with. So, on this paper, you will be asked to fill in atoms and make a representation of atoms in each state of matter. So, we have here an apple, water in a cup, and this spoon is supposed to represent gas. So you're going to go ahead and put Cheerios inside the shape like we would see if we were to make a representation of the atoms. So if there's atoms in here, how would they look? So I'm going to go ahead and hand this out to each and every one of you. And like I said, make sure these Cheerios are staying on your paper and that we're using them correctly. So let me hand these out to you. When you have completed the activity in the handout and you think everything is done, go ahead and raise your hand and I'll come over to let you know if everything is in the correct placement. And then if so, I will give you glue so you can glue them down. Are there any questions? All right, perfect. I will go ahead and hand everything out to you. And you can go ahead and start. All right, so at this point, I would give the students as much time as they need. And I would just be walking around kind of observing what the students are doing and going ahead and starting to go to the students with their hands raised and telling them if it's correct or if they need anything fixed. So here's an example of that. Oh, Mr. Dog, I see you're done. Oh, wow. So looking at this is a great job. I like how you made sure to have the Cheerios in between the lines, and it keeps it nice and neat. It seems like you may have mixed up your states of matter. How about we go back and look at our definitions of our new vocabulary and reread the solids, liquids, and gases. If you're still confused after that, go ahead and raise your hand again and I'll be over and we can look back at the video and take some notes together. Oh, Mr. Dog, I see that you went and fixed what you did. Awesome. This is very nice. Here's some glue, and I'm going to let you glue that down. Okay, class, so now that everyone's finished with our Cheerios activity, to wrap up, let's look at that fill in the blank worksheet. Let's look at that fill in the blank worksheet. And we're going to go through it together. And I'm going to write the answers up here on the board just in case you got anything wrong that you want to correct. We'll have this up here. So go ahead and pull out your worksheet. All right. So for question 1, it says, all matter takes up blank. Can someone raise their hand with the answer to question 1? All right, so great try. Let's take a look at this one more time. All matter takes up blank. Can you phone a friend to maybe help you out while you go back and try to find a definition or maybe a new answer? All right, you want Mr. Broccoli to help. Mr. Broccoli, what do you think the answer to this all matter takes up blank? Yeah, you're absolutely correct. All matter takes up space. Great job. Thank you for answering me. All right, so here I would go down the list and call on each student and let them raise their hand, and then I would have this worksheet filled out for them, so then they can change their answers if they need to, and then they'll have this worksheet to go back and look back on throughout these 3 lessons. All right, so that was a great job, class. Thank you for everyone who participated. You can go ahead and put those papers in your science folders and pack up your vocabulary notebooks and put them under your desk. I am going to go ahead and I'm going to give you a quick little worksheet that you're going to go ahead and fill out the answers. Make sure you write your name at the top, and when you're done, go ahead and raise your hand and I'll collect it from you. At this point, I would be giving them probe 3.